Good morning, Year 13. I do like calling you guys Year 13s. I think it's nice. How's it going, everybody? I know that I'm a little bit early. Suddenly realizing I'm 2 minutes early, and other people will they'll probably still be in other lessons. So there's no rush to get the register done today, which I think is probably quite a nice thing. Say hi if you're on the chat. I know. Oh, hi, Ria. Hi, Dan. Hi, Ben. Wow, Ben. What's going on? Ben, you're actually here like third? Dude. Wow. That must be a record for you. Dan and Ria, it's so nice to see you all. Hey, Emma, making big changes. I like it, Ben. I like it a lot. Got Emma, got Tenzi, doing well. Wow. You guys are on this morning. Like I said earlier, I'm very aware that I started too early. And I do forget sometimes. I mean, I've been running quite close to the wire, really, on some of my lessons. And I'm just very aware that there'll be other teachers doing something similar. And so there's a good chance that, people are going to be, they tend to be, in a couple of minutes late. So there's no rush. Hey, Kayun, lovely to see you. So how is everybody? How's everyone coping with the lockdown? Is everyone okay? I miss seeing you all. I miss being in the lab and doing chemistry. I miss saying five to Ben. Oh, funny. Oh, good times. Okay. So, I love it, Ben. Love it. So, last lesson, we were looking at Unit 4 kinetics. And we were looking at this concept of orders of reactants. And, there's Jasmine coming in. Morning, Jasmine. Lovely to see you. Sherlyn, of course, is still on the register, which is a bit of a nightmare. I need to send an email about that, because otherwise we're just going to mark her as out all the time. Bit of a nightmare. Oh, morning, Mika. Lovely to see you. That's a bit of a tricky one, that. What do I do about Sherlyn? I'll send an email today. Got me. So I'm just missing Ivan, Nikita, and Donna now. Wow, you guys are proper on it this morning. It's great. So yeah, like I was saying, we started the process of looking at A2 kinetics, and we were talking about this idea of orders and how some reactants don't seem to make any difference in terms of if you change their concentrations, they seem to have no effect on the rate. Others have this directly proportional change in the rate, so they're described as first order. And then the ones that were second order had this squared power. Yeah, that they were the ones that, and I think lots of people would agree. Oh, look at that! Oh, look at that! I've got Kate. Kate's just arrived. She's one of my year 10s. Kate, oops, I love that. That's brilliant. Do you know what? Funny that you should say that, Kate. I actually thought I was teaching you lesson 2. I set up all my lesson for your lesson, all my slides and whatnot, and I was like, oh no. But it's lovely to see you. You can always tag along on my A2 lesson if you like. I've got Donna doing really well. We're nearly there now. Just missing Nikita and Ivan now. I'd love to know whether or not that there are other teachers who are running right to the wire. I'd love to know that. I will see you, Kate. I think I see you period 3. Yep, see you period 3. Also, year 13, I'm going to be setting you guys some homework today because we come to the end of orders today. So you guys are going to have, sorry, I'm late. Oh, there's Nikita. Just Ivan now to go. I'm actually going to start the lesson. I'll mark Ivan as missing, and then when he arrives, he can then sort himself out. I don't know what to do with I'll do the red. I'll tag him onto the register when he arrives. So okay, let's crack on, folks. I still don't know what to do with Sherlyn. Anyway, I'll leave it like that for now. Okay, let's share screen. So we're continuing this concept of orders today. So last lesson, it's always nice to do that review of last lesson. This is what we covered last lesson. I do love my tablet for this, you know, because as a teacher who writes all his own notes all the time, you know, I'm very aware that it's always nice for me to be able to do this review. And because my tablet saves everything, we can just kind of have a quick review of our learning objectives. Last lesson, we began the process. We first of all eliminated all of the other factors. And we said, okay, at A2 chemistry, we deal with concentration. And it becomes this very specific focus. These don't disappear. Yeah, these are still asked. Yeah, these are still asked at A2 with the explain running kick-ass. These are still done. But they now have much more pressing things to ask you in terms of concentration. Oh, there's Ivan. I'll mark you in, Ivan, on the register. Then we talked about this idea of orders and how some reactants play a much more important role in concentration and its impact than others. We will link that to mechanisms later on because we've started looking at mechanisms in AS organics, and we realize that in mechanisms there are these attacking molecules, and we can actually start using the data from the kinetics in A2 to be able to actually suggest whether or not mechanisms are correct, which is really, really cool, by the way. It gives me goosebumps whenever I talk about it. So we did orders of reactants, and we covered all three of the major orders. We covered 0, 1, and 2. You do not need to know any others. Yeah, the calculations will always spit out these in terms of whole numbers, so try not to worry about that too much. And then you needed to use data, and we were running what Einstein used to call thought experiments. Yeah, thought experiments. And we were just kind of playing around with numbers and looking at what it meant when you saw these changes and how that tells you what their orders were. Kayun asked some amazing questions. You know, you can only find out, you can if you have a mechanism, you could predict, or you could suggest what you think an order might be from a mechanism, but that depends if the mechanism's correct, and you'd still want to run the experiments to be able to determine this. So today's lesson is an extension of this. Yeah, and I've got 3 learning objectives. I'm actually going to add a fourth. Going to add a 4th learning objective to this. Yeah, and this is I need you guys to know. I'll make that pen even smaller. Yeah, I need you guys to know 4 learning objectives, so I'll add one to this. And that was to know what is meant by the overall order. Yeah, it's always nice for me to include the learning objectives because it helps me make sure that I'm hitting all those points that I know I need to make. So stepping. And we're going to drop immediately back into our thought experiments. Yeah, because before, when we were running them, I was giving you the most simple data that's possible to get. And that's not what you're going to see in reality, of course. So stepping is my first one. Then we're going to drop to rate equation, and then we're going to be be able to create a rate equation from data and use and understand and know the overall order. That is really where we're going with this. Okay, so experiment number 1, EXP1. So this is, again, thought experiments, and I'm going to spell it right this time. Thought experiments. And unfortunately, thanks to lockdown, this is kind of all I've got. So sad. I miss my chemistry. But okay, thought experiment number 1. So we're going to go back to the simple ones. We're going to go back to A and B. Yeah, and we're going to be changing the concentration of A, changing the concentration of B, and we're going to be looking at the rate. That's what we're going to be doing. Our usual thing that we saw before. Now, just to let you know, at this point, I always, as things appear in my mind, I tend to like to spit them out. I do want to always let you know that this is actually, this setup, this routine, this pattern of data is the one that you are most likely to see. Yeah, and it's the one that kind of, for me, always makes the most sense because you read left to right. However, just to make sure I've covered my bases, there is an alternative setup, which is every now and again, what will happen is instead of having this and then EXP1 and then EXP2 and EXP3 and then giving the data lengthwise, yeah, it allows you to do these comparisons going up and down, yeah. Every now and again, what Edexcel and in fact all the exam boards do is they will reorganize the table. Can I just point out, I hate it when they do it, yeah. Every now and again, they will do this, yeah. And I'm just making sure that you guys are aware of this. And there isn't really much I can do about it, yeah. All I just have to recognize is that you're hopping this way. You know, if you started off at 1 and went to 2, then that's the ×2, and you're going, oh, so what happened to the rate? And it just takes a bit of practice, and you've just got to be, and you always hope that they don't do it, but every now and again they do. I'll show you some of those questions. We're approaching the question point at this stage, by the way, and I do need to get on board with making your support sheet and having everything built for you guys. But anyway. So going back to this, so everyone remembers our little thought experiments, and we're going to start off easy. Yeah, we're going to start with 1, 1, and 10. Let's keep with the same routine. Remember, I'm not trying to expand. I'm not trying to make this more challenging at this stage. I'm just trying to get across that basic understanding to get everyone to the same point before we then start going, okay, guys, let's look at horrible data. Yeah, but at the moment, we're just playing easy. So in experiment 2, what we're going to do is we're going to double A. Yeah, let's double A and I get 20. On the chat, please. What is the order with respect to A? Let's see who gets in there first. So again, you're doing the same process we did last time. You're looking at what the multiplying factor was. Donna's in there first. Well done. Look at that. Donna, Dat, Ivan, Kayun, Tenzi, this is great. Everyone's on this. Thank you, guys. Brilliant. Thank you. So everyone here is going, fine, get this. Yeah, I should be having more people on the chat than that. I'd like to see Nikita taking part. I'd like to see Ben, Emma, Ria. I'd like to see you trying to get in there on the chat, please. It's me ensuring that you're still in the classroom and not just wandered off from your laptop. yeah. So this was a ×2, and this was a ×2. And you go, it's a directly proportional setup. If I double A, the rate doubles. We can now assign, as a result of that data, we can now say that A is first order. We like it. Yeah, like in Star Wars, the first order. So let's now have another string of data. Remember, these are called strings or runs. It always entertains me, and it's really bad that I chuckle, when I see the exam paper and they go, just have a look at the runs. And I'm like, oh, it always makes me chuckle. I'm like, the runs. So EXP3, let's make this a little bit more challenging. Yeah, let's now do this. And this is where I need to make sure that I get this correct. Ugh. Right, guys, what is the order with respect to B? Let's see who can do that one. Go on, guys, impress me. Impress me. What is the order with respect to B? Now, isn't that interesting? Everyone's like, ooh, that's clever. Dat's in there first. Ivan's in there at 1. I like it. Donna's on a 1. Kayan's first. Oh, wow, you guys are on this. So just to explain it, this process is called stepping. Thank you, Ria, for contributing on the chat. I do appreciate that. This process is called stepping. It's called stepping rate data. So, and you guys have actually done this instinctively, which is great. The numbers make it easier. Now I'm just introducing you guys to the process that you've done in your head and it might be the fact that you've done this in your head and not really seen what you've done, and I tend to see that when I teach. What we now did is you guys actually compared EXP1 and EXP3. That's probably what you did. Now, can I just point out, Ria, this is kind of dumb question, but when you give the order, is it always in respect to the data from the experiment just before? No, Ria, you might get a huge number of strings, like experiment 2 and 3. No, not at all. I'm about to use 1 and 3, Ria. Yeah, I'm about to use 1 and 3. I will then use 2 and 3. The answer is you might actually need to use 3 strings of data to be able to determine someone. Yeah, you might have to use more than 2. So, okay, what we now did is, here was the data. In EXP1, we had A, A, B, and rate. Yeah, I'm just rewriting it to make it easier for me to show you what's going on. Yeah, so we had 1, 1, and 10. And EXP3, I'm just cutting out the data just because it makes it a bit easier. That went to 4, that went to 2, and this went to 80. But we now know we couldn't have done this. We couldn't have determined B if we hadn't already determined A. We know if there are 2 unknowns in orders, we can't do it. We've got to take this one piece at a time. We now know, and I'm going to change my color for this. We now know that A is first order. That was too fat. Don't like it. Try that again, Mr. D. Yeah, A is first order. And this B is the question mark. So what we can now do is we can do what's called stepping. So we know that we have multiplied A by 4. And here's the stepping. The stepping is the fact that the rate change has been created by 2 different people. And the first step is the one we know about. This change is caused by A, the change in concentration to A. And that is a first order times by 4. So we know as a result of changing A that we can now predict that the rate would have become 40 as a result of A. What that now means is this change here, this change from 40 to 80 must have been caused by B. And we don't know its order. But what we do know is we do know the multiplying factor. The multiplying factor of B was a times by 2. And we know that the number also doubled. So this is also a times by 2. And that now confirms to us, because they are both times 2, that B must have been first order as well. This is called stepping. And it does take a bit of practice, because the problem is they're not gonna give you nice data, ever. It's gonna just be horrible, horrible data. So, do you know what? At this point, it's worthwhile having a look at some real questions. So let's see if I can actually find some. I do actually have, I've already actually given them to the other class. I actually gave them too early. I am very aware of this. I wasn't meant to give them that until after this lesson, and I totally missed it. Yeah, it was my fault. It's funny that giving a homework out of sync of lessons at times does not do me any favors. It's gonna be in where would it be? It's going to be in BC files, Blue Coat files, pen drive. Oh, I don't know where it's going to be. Was it here? BC files, Blue Coat files, chemistry folder, staff. Climate. These are ones that I've been sharing with people. This is why I know where they are. There we go. Kinetics number 1. Right. Let's hack some data, shall we, folks? And I just want to show you that these are going to get a little bit messy. There you go. So let's try this one out. I'm going to cut it. I'm going to snip it. And you know what? Let's start off easy. I have loads of these, by the way. I've got loads. These, of course, aren't realistic. Do you know what? I'm actually going to take the whole thing because it's quite nice for me to do that. I'll explain why now. Typical. Nice. No. I don't know why it's going suggest ink feature. Oh, what? Go away. Try again. No. There we go. I just want you guys to be aware that the equation makes no difference. Yeah? And that is important, that. Let's have a look at this one. So these are just a series of questions that I've collected over the years. Yeah. And this just happens to be one. Okay, so they've given you nice, easy data. This is not an exam level question. This is not A2. Yeah. Is there such a thing as half order? Dana, yes. There's actually orders pretty much to any decimal place, but you don't deal with it because the maths is horrible. Yeah. You get all kinds of disgusting, crazy mathematics with differentiation, integration, and all kinds of horrible things that you need to be able to use to understand how the order actually works. And you don't cover it at A level, Dana, because it's not required. They're trying to get this basic understanding of what an order is, how it changes with in terms of, oh, no, don't say fun, Dat. Dat, I bet I could dig up some of my old degree homeworks and give you some of those ones if you want to try it. It's horrible. I didn't like it. I dropped it as a result. Yeah, I know. Maths let me down. Okay, so guys, here's your question. It's on YouTube. I would like you to tell me what are the orders with respect to A and B, please. Please go now. What I'm going to do is I want you to pause the video, work out A and B, and then you can watch me explain it. I know this is going to put us out of sync, and then you can forward the video and bring me back into sync. Look at that. Ivan's already finished. Interesting. Okay, so let's run it. So first thing we're going to do is we're going to compare experiments 1 and 2 for A. Yeah, because you're going to ask me why? Because B has been kept the same. I tend to call it KS just for keep same. Yeah. I love the fact that I've got 3 people on the classroom have already finished. That's outstanding. So what happened here? So we multiplied A by 2. Yeah, multiplying factor of 2. What's happened here? It's gone up by times by 4. Right, that immediately flags us as A to B second order. Because remember, that there translates to a times 2 concentration, which is what the brackets mean, squared, which gives us a rate change of 4. That makes total sense. So well done, guys, for A being second order. Now we need to do stepping. Oh, no, we don't. No stepping required. Isn't that nice? That's lovely. I'm going to change my color. I'm going to change my color here. Let's go for green. I'm now going to compare 1 and 3. And the reason being is A has been kept the same. Yeah, KS. What did I do here? I multiplied that one by 2, and the rate has kept the same. B is 0 order. Well done. And why is that? Because the concentration of B, if it's to the power of 0, if we double, and I love the fact I've only got 3 people who've done it. It doesn't matter, of course, you might have paused the video and have a go at it. Yeah, I have times that by 2, and to the power of 0 means I'm going to have a rate change of 0. Yeah, 2 to the power of 0 is 0. So 0 order, 0 change. So at the end of this experiment, we can say that A is A. I should really stick with my same color coding. I do like doing that. A is second order, and B, which I'll do in green, yeah, B is 0 order. Okay, so at this point, and you know what? Before I rush onto a rate equation, I'm going to give you guys another one to have a go at. Don't worry, by the way, guys. This might make up part of your homework. Yeah, let's go for a new one. I think they're going to get steadily harder. Let's see what this does. Yeah, edit, copy. Let's go for the next one. Paste. There we go. Right, guys. Again, nice and straightforward. Very easy question. Can you just give me the orders, please? Order for D and E. Off you go. Yeah, I had 3 people before. Can I ask Ivan, Dana, and Kayun, can you not post on the chat your answer? Can I now see Ben, Dana, and Ben, Ria, and I'd love to see Jasmine or Tenzi having a go at this, please. On the chat, give me the orders. Yeah. So have a go. This one's more complicated because stepping's now needed because D has never been kept the same. So this is going to be more challenging. So, do you know what? I'm tempted to wait now. Do you know what? While I wait, I'm going to set up the next question. Why not? And now you're starting to see numbers getting more tricky because it's interesting, isn't it? Because what you'd like to think is, you know, as you get to grips with this, you'd be like, oh yeah, I've got the hang of it. And then it's very easy to make the numbers so it gets more tricky. It's very easy to do that. Oh, I love it. I've got 10. Oh, look at that. Dat, did you just give me the answer when I told? Oh, yeah, my bad. I didn't actually tell Dat not to. Did Dat do it before? No, he didn't. Well done, Dat. I like it. Dat first, D first, E first. I like it. First. Love it. Thank you, guys. Do you know what? I need to start doing that more. Staggering the questions on the chat. Lovely. Thank you, Jasmine. Thank you, Emma. Thank you, Ria. Thank you, Ben. Thank you, Tenzi. Thank you. That's great. Love it. Right, let's run it. Let's check. By the way, some students often ask me, you know, can you just see the numbers? And I'm like, no, I have to run the same process you guys do. Yeah, this does not get, it's never instantaneous. You have to take your time with it. It's very easy to jump to an answer without checking it and making silly mistakes. So first thing is, we can first of all look at experiments 4 and 5. And we're gonna do D here because we can see that E has been kept the same. Yeah, KS, keep same. So what did I do here with D? I multiplied it by 4. The numbers get slightly more tricky. I'm now using decimal places, but in reality, it makes no difference at all. What did I do over here? I times by 4. That's nice. Yeah, so I can immediately say I now know that D is first order. I made a times 4 change. Yeah, I know that because I had a times 4 concentration and it was to the power of 1. I'm going to have a rate change of 4. I like it, times 4 as well. Makes sense. Right, now we need to get E, but now we need to run stepping, right? So, okay. Now, can I just point out in an exam, when you do stepping, my recommendation here is always to do it in pencil so you can rub it out after. Yeah. Because it does get a little bit jumbled if you've got lines everywhere. I have seen all kinds of clever things that students have done, extracting data. I've seen them doing it in different colors. But in reality, the way that I always suggest to do this is do it in pencil on the data table and then just quickly rub it off afterwards and then do the stepping. Yeah. So we now know that D is first. I'm actually going to keep it there anyway, and I'm going to change my color and go from the other side. But when you get to 3, it becomes a little bit messy. So I can choose which either experiment 5 and 6 to compare or experiment 4 and 6 to compare. It doesn't matter. I'm actually going to pick at random 5 and 6. Why not? Right. So I now know that D is first order. So I can apply my stepping. So from here to here, I have doubled D, 0.4 to 0.8. What that means is the rate as a result of that, yeah, as a result of D would have also doubled. Times 2 as a result of D. So that would have got to 40. So that is what would have been caused by the change in D. Right, so I'm going to go another times by 2 as a result of E. What did I do to E? I also timesed it by 2. Right, times 2, this is first order. Yeah, so E in the experiment, E's concentration, let's just check it. E's concentration was doubled. Yeah, if it's first order, that would cause the rate would therefore also double, which it has done. So we can now say that D is first order, and we can also say that E is first order. Everyone is on this, so I love this. How will that affect the way we do this? Huh? Do what? Do what? Do what, Ben? How will that affect the way we do this? I don't know what you mean, Ben. Huh? Ben, I don't understand your question. Do what? I love you then pointing me back to the question. Is it not sending? Do this. Have you sent something else? I don't know. Let's go to the next one. They'll steadily get harder, folks. They will. Let's go to the next one. As you go through the process, everything tends to just slowly get more and more challenging. Let's go to the next one. Paste. Right. Wait, is no one else seeing it? See what? Like the equation above. No, I can't see it, and I haven't had a... How would you do this? Wait, what? Ben, I think your equation's been lost in the mix. You said, how will this affect the way we do this? And then you haven't posted, it's like above the table. Above the table. Above the table. Oh, are you looking at the sheet on the one that I've paused? Ben, I don't know what's going on. Just, Ben, I'm sure it'll come out in the wash in a minute. Otherwise, you can just message on the chat again once this becomes clearer. Let's just stick with doing the next one. No, I'm up to sync, I think. Yeah. Oh, he's talking about D plus 2E. Yeah. So Ben, you're wondering what impact that has. The answer is nothing. You're going to need this though. So, okay, Ben, I understand why you're asking. Yeah. You're wondering how the equation has anything to do with the first and second order. Agreed? Yeah. Well, that's due to what's called the mechanism, Ben. So, okay, all right, you're jumping the gun a bit, but it's okay. We've now seen that D is first order and E is first order. What that tells me in the mechanism is that one particle is reacting with one particle of D in what's called the rate determining step. So it means that this equation here cannot be a direct mechanism, because in this equation, it says that two E's react with D, but that cannot be the case. This is the overall equation, is what this is called. You're jumping the gun, and I haven't quite got there yet. Well, I know I haven't, but it just means that there's going to be two steps. D is going to be reacting with one E because the kinetics here says so. And that's going to probably form DE, yeah? Probably form DE. The problem is that, well, no, you see you've got F and G over there, yeah? So probably a D and E, I'm getting into mechanisms and I don't really want to, but just to finish that. So me trying to put together a mechanism. And the problem is these questions are not really designed to do this because it's D and E, so you can't really see anything else in it. But we could argue that that makes W, no, E, F, G, H. Let's make H. And then H reacts with another E to make F and G. And that might be the mechanism, Ben. The reason being is, yeah, and this is step one, yeah, and this one's going to be the slow step. Yeah, this one, step two, is going to be a faster step. Yeah, and that's the H is going to be an intermediate. Yeah, look what happens when you cancel out and you put it together. You get 1D plus 2 E's goes to F and G. Yeah, it gives you back the overall equation that was there, but it was in two steps because the kinetics says it can't be a single one step process. Does that make sense? But don't worry about that. We're not quite there yet, Ben. And I don't want to get lost in doing, because that's a whole different lesson, that. Predicting mechanisms, and I've got to show you real questions for that because the questions are they're very specifically built to solve that, so don't worry. Right, guys, next task, please. Give me the orders for J and H, please. Off you go. Now, this time, who have I not had contribute? Nikita, can I please have you spitting me out an answer, please, on the chat? And can I also have Mika? Can you also give me an answer on the chat? for the order with respect to J and H, please. Off you go. So no one else post on the chat, please. Just Nikita and Mika, please. Can you give me the orders with respect to J and H? That'd be great. Let's just see how long it takes. Whilst you're doing that, I'll get the next one ready. You can pause the video if you wish, so you can keep the question, because otherwise the question's going to vanish. Yeah, I'm very aware of that. That's tricky, isn't it? This is where I should be working on the two laptops, because my notes is on both and it syncs to both of them. I could have been sorting out the next one. Oh, can I do that? No, that would just be a bit epic. I don't want to start doing that. Ew, let's not do that. Nah. Let's see how long it takes Mika and Nikita to give me an answer. Everyone, of course, should always be doing it. All of you should be finding out what the answer is. Yeah, and be waiting with your answer. But I'm just waiting for those two to post. Just it ensures that I know that you're still there. And it also means that I'm getting that feedback from everybody. Being able, and I can offer some support then if I need to. By the way, this is the first time I've done this. My webinars are evolving. I want to say they're getting better. Anyway. I'll wait for another 30 seconds and then I'll go through it. What you can do is, Mika and Nikita, if you could pause your video and then you can have a go at it and then I can go through it and then you can still be the first next people to post on the chat. So, okay. So Jay, what we're going to do is right. So I'm looking at the data and the first thing I see is J's been kept the same. Yet between experiments 1 and 2, J has kept the same. So I'm going to do these two here and I'm going to be working out H. Yeah, do this in green. So this one, what have I done? Oh, I've divided by 2. Notice that you can do this, guys. You don't have to multiply. Yeah, you can divide just as easily. Now, what's happened to the rate? The rate has been divided by 4. Yeah? If you wanted, by the way, you do this on your calculator. When the numbers get really disgusting, and some of you guys will, yeah, some of the data will get disgusting, you divide the bigger number by the smaller and it'll give you the factor. It'll give you the multiplying or the divide factor. Not complicated. I've just done 12 divided by 3 gives me 4. That's all that I've done. So it's a divide by 4. That means that H plus, which is acid, yeah, the H plus, which was a divide, I should do this in 2 steps. The H plus concentration, yeah, is going to be second order. The reason why is because the H plus was divided by 2. If you have it to the power of 2, then the rate would be divided by 4. Agreed? Nikita and Miko are definitely not replying on the chat. I wonder whether they're not there. I'll chat to you guys about that later, making sure that you're attending and trying to be there with it. I know that there's going to be delays and whatnot. I am aware of that. This is where I should be running a Hangout side by side, so I can message people and be like, are you still there? Definitely should be doing that. Okay, so we've now got H plus as 2. We can now say H plus acid is actually a second order reactant. Yeah. Okay. By the way, what that definitely means is it's, oh, could you have a catalyst? That's 0 order. Could you have a catalyst with an order? Yes, you could. It could be in the rate determining step and still be regenerated. Could. I'll stop talking now. Right, now I need to work out J. Now, the problem is there's no place where H plus has been kept. I've suddenly realized I've flipped over to the different side, haven't I? I'm just going to move that over to there to keep similarities. Yeah, there's nowhere that H plus has been kept the same. So I'm going to change my pen color. Let's go for red. Yeah. Yeah, okay, go for red. I'm going to choose 7 and 8. Why not? So J has been divided by 2, okay? And H plus has been doubled. Ah, look at that. Right, so we're going to step this with a person I know. So to step that with H plus, the H plus was times by 2. And it was second order. Yeah, and if that's, so that's going to be times 2 squared. So times by 2 squared, yeah, is 4. 12 times by 4, 48. So I would have got to 48 as a result of H plus being doubled. Now, any change is as a result of J. So that there has been divided by 2. What did I do to J? I divided it by 2. So J, J must be first order because J's concentration was divided by 2 and the rate was also divided by 2. Which gives me a rate change of also divide by 2. Is everyone okay with this? Cool, okay. Right, are you ready for the next? That was an interesting to see the divide appear, wasn't it? Yeah. Now, I'm very aware that I've only got 15 minutes left of my lesson. We have now covered stepping. I'm just going to let you know, I will post this thing with you, and I just want to show you some of the awkward numbers. And these aren't even that awkward. It's when you get 10 to the powers that appear that freak everyone out. Okay, I need to move on to my next learning objective. I'll send you that homework. So everyone now can do stepping. Everyone understands the process of it. What we now need to do is talk about the rate equation. So I won't take it yet. We haven't done it. So, okay, guys. So what you guys are all now thinking is, okay, so why are we doing this? Well, the reason why we're doing this is so that we can predict what happens in chemical reactions when we make changes on an industrial scale. And so we learned that rate, this is AS. We can put a subheading, please, guys. Can we put a subheading of rate equation? Rate equations. Now at AS we had one. At AS and /IGCSE and GCSE, rate equals change in product, change in the concentration of product. You could also have, by the way, change in reactant as well, over change in time. This still stands, but this is practical basis. This is a practical output. This is what you would do to work out this column. That's what you do for that. If you want to work out rate data, that's what you do. Do you notice, by the way, that it says initial rate? I also need to talk about that in terms of rate graphs. I'll do that as well today. But that is how you get that data. However, as a result of this, we now get an A2 rate equation. And the reason why A2 rate equation is, I've lost my mind. A2 rate equation is all about concentration. Rate equation all about concentration. We get a new thing specifically for A2 chemistry. Oh, I've lost my marbles. There we go. Concentration. And so here it is. So now I need to, you notice that my learning objective of here said, come on, is to understand the rate equation. Okay, so now those people who are mathematically minded, this will come more easily to you guys. So we now know that if we let's look at question number 1, because this one was really easy. We knew that we have got, I'm just going to rub off the data here. And understanding rate equations is tricky. So we know that for experiment number 1, for the concentration of A was 3, the concentration of B is 1, and the rate was 10. Well, hang on a minute. We know that the rate of reaction is, and we're looking at this from a concentration standpoint, the rate of the reaction, which was 10, is proportional to the concentrations. To the concentration of A, to its order of 2, and the concentration of B to the order of 0. Well, what that now means is that B doesn't need to be in the equation. So the first nota bene to make here is that a zero-order reactant does not appear in rate equation. I'm just going to put EQ. First important thing to note. So it's going to disappear. But and by the way, I'm just going to check that I got my values right. It was, yeah, A was 2, B was 0. Cool. So it's not going to be. So what we can now say is that the rate of the reaction is proportional to A to the power 2. We can say this. We know that if I change the concentration of A, it's going to change the rate. And that is all we're changing. Well, the problem is with calculations is you can't have a proportional sign. Excuse me. Right, year 13. How do I get mathematicians in the room? I think this is all of you. Can you please tell me, how do you get rid of a proportional sign mathematically? Who's going to be the first person on the chat? Come on, come on, come on. Come on, guys. Add a constant. Ivan is on it. Thank you, Ivan. We're going to add a constant. So, notably, to remove proportionality, yeah, to remove that, and I'll just put proportional sign, we add a constant. Add a constant. And our constant is K. So we now know that rate is equal to the rate constant, which is what this now is. K is called the rate constant. Yeah, and that is going to be, and then it's going to be multiplied by A to the power of 2. And that's going to get us to the rate at a constant. Well done, Ivan. So guys, you've just built your first rate equation, and they're really, really easy. What we're now going to do is I want you to realize that I love chemistry because there's patterns. Patterns make my life easier. Do you know? And this is what I now need you to get. So you guys are now studying A2 Chem. You hear the word rate. Someone says to you, kinetics. Someone says the word rate, and you need to just go, rate equals K times blank, 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 whatever. You just need to rate equals K times da, 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 da. You need to, that needs to be fixed in your mind. Yeah, I need you guys to understand that you hear rate, you hear kinetics, you hear kinetics, yeah, you think K. The reason why year 13 is because you're going to find a lot more Ks coming your way. So just to let you know, this is called K. I'm just tempted to give you the Ks. Really quickly. The Ks. The Ks of A2 Chem. Number one is the original K. Yeah? The original K is called the rate constant. Then you are going to see KC. This is the Chatelier's constant. Can anyone guess what that is? Yeah. The C stands for Chatelier. What's the constant? What's it for? Come on, guys, on the chat. Come on. Keep up with me. The Chatelier constant. What was it for? Come on, come on, come on. I'm running out of time on my lesson. Oh, come on. Equilibrium. Smashed it. Thanks, Karen. Equilibrium constant. And just to let you know, well done, Dat. Well done, Ria. Well done, Tenzi. Good job. Guys, this one is the original. Everything, I can bring all constants back to the original. I can show you how they're derived. It's going to be so cool. You're going to love the maths. I hate the maths, but whatever. You're going to get another one. You're going to get Ka. Does anybody want to guess what the A stands for? Oh, I love it. At least the chemists were smart. Oh, I do wish it was Ke, though. Ke would have been easier. Yeah, but the problem is that Ke is kinetic energy. So they had to choose C for Chatelier to make it easier. So people didn't get them confused with kinetic energy. No, good idea. Dat, You're right, but wrong. Kayan, you're right, but wrong. It's only one of them. It's the acid. It's a weak acid. It's the acid constant. Yeah. This is the weak acid constant. There's also KB. Guess what that is? I love this game. What about K for Kelvin? Yeah, I know. I actually think it might be a lowercase k. I think. Base constant. Weak base. I'm going to put weak up there. Weak acid constant. Weak base constant. I love it. Next one, KP. Oh, God. Can you guess? This is pressure. Equilibrium pressure constant. It is an equilibrium, though. Equilibrium pressure constant. It's for gases. This is the pressure. Well done, Dat. We're gonna get another one. Oh, so many. KW. Guess what the W stands for? Oh, this is a fun game, isn't it? But everything came from the original. Everything stems from here. If anybody wants me to derive them as we go through the topics, I can. Oh, wait, Ka, the acid dissociation constant. Yes. Where Ivan is on it today. Well done, Kayun, as well. It is the water constant. Equilibrium of water constant. Yeah, KW. Isn't it amazing? Chemists were at least nice about this. Oh, is there any more that come into my head at the minute? No, I think we're okay for now. It's a fun game, though. I think that's actually all you need at A2. Yeah. Oh, I shouldn't laugh, but I do. Let's move on. So, okay, let's go back to our rate equation, shall we? Okay, so rate equations. Back to this. Rate equations. Okay, I've got 5 minutes left. 5 minutes to go. Right. What is the rate equation for this one, please, folks? And you realize it's dead easy. But the questions are part and parcel of the same bag. If you cannot do that original question for working out orders, you can't do the next one. Yeah. What is the rate equation for B? Rate equals K. That's how you all start. Yeah. That's as soon as you hear this rate equation. Rate equals K dot 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 dot. And this is going to be D to the power of 1 and E to the power of 1. We're done. Let's look at the next one. What's going to be the rate equation for this guy? Rate equals K. H plus to the power of 2. And J to the power of 1. That's the one. Thanks, Dana. You're on it. That's correct. Okay. So I think everyone's kind of understanding. So with the rate equations, we have to say in the steps of it, it's work out orders. Work out orders of reactants. Step 2, rate equals K dot dot dot, and then you just add in your reagents. Yeah, rate equals K, A to the whatever it would be. Yeah, B to the power of, yeah, whatever it might be. Yeah, these here come from step 1. If you can't do, I should call them step 1 and 2, step 1, step 2, step 3. Yeah, if you can't do step 1, you can't get to the rate equation. Do you need to specify K? Kn, they're going to ask you to calculate it. You know that. Yeah, this isn't complicated. But before we get to that, by the way, it's not complicated, is it? You just reorganize. Yeah, they're going to get you to do all this. Step 4 will be calculate K. Calculate rate constant. Calculate K, which is just a simple rearrangement. Yeah, you choose a full string to calculate K. Yeah, choose a complete string slash run of data. Yeah, can choose a complete string. So if I wanted to work out the rate constant for this guy, I'll just choose a complete string of data. I'm going to choose that one. Yeah. I now know I've built the rate equation. I can now work out the value for K for this. Yeah. And by the way, there's only one thing that changes the rate constant. Oh, no. I'm wrong. Catalyst does too. Temperature. Catalyst. Surface area. No, surface area does. Oh, surface area, it changes concentration. Oh, no, that's the problem. Parts per unit. Parts available for collision. Yeah, you could say that surface area changes it because it is a solid. Yeah, but in effect, it's a change in concentration of a solid reactant. That's tricky, that one. You can't measure the change in surface area, so you'd apply it. It'd probably be a zero order reactant. Anyway, not that it matters, but I can reorganize this. Yeah, I'm sorry, saying things out loud there that I probably should have just chilled out with. Rate, reorganize, move those over there, divide them. Rate divided by h plus to the power of 2, j to the power of 1 is going to give me the rate constant. It's also going to give me its units. Yeah. Right, guys, last thing I want to mention is overall order. Yeah, this is really just a little tiny dot. I know I've got 1 minute left. Yeah, and it seems like a bit of a throw in. I will explain this next lesson. Remind me. Overall order. The overall order, rate equals K. Rate equals K. And I'm just going to stick with the one I did before, 2 and 2. The overall order, yeah, overall order is 4. It's the sum of the orders. Yeah, it's the sum of the orders. That's all it is, the sum of. Yeah, and you can just make a note of that. Overall order equals the sum, is the sum of all reactant orders. I'll explain why that's important later. Next lesson. Guys, that brings us literally to the end of the lesson. I just want to check my learning objectives. So we understand the rate equation and proportionality and how the K came about. We can now create a rate equation from the data that we've created, and everyone now understands the overall order is the sum of the orders, and we will talk about that more next lesson. It was a tack on my learning objectives. But it just means that, I'm going to submit you a homework to do. Guys, you are going to be finishing off this homework for me, and it says for each, deduce the rate equation for each of the following. So the rate equation, all you need to do is give me the rate, because the rate equation will give me what you know as the orders are. Yeah, is everyone okay with that? And the last question is, for each of the rate equations, you deduced in question 1, calculate the rate constant and its units. Guys, have a go at the units. Yeah, if you can't do it, don't worry. I'll explain the units next time. Calculate the rate constant, and then we'll do the units together if you want me to next lesson. Have a go at doing them. If you can't, then I'll go through that next lesson on my webinar. Right, God, guys, we managed to get through a mammoth amount of chemistry. Guys, that was a really good lesson. Thank you so much for contributing so well on the chat. It was really good. Nikita and Mika, I do feel like I haven't heard from you at all. I hope that you're still there and you managed to get to the end of the webinar. I will just send you a message on Hangout just to check that you guys are all okay. I will see you guys soon. Have a great rest of your day. You are so welcome, guys. It's been so good to see you as always. Yeah, I hope you're all well, and I miss you all loads. Take care, be safe, and I'll see you guys all very soon. All right, bye, guys.